thank you so much for giving me a tour through this House Zero. It's so incredible to see kind of like the outer reaches of what this technology is capable of when you kind of with no reservations throw it all at the wall and make a design that's with the intent of inspiring awe and creating an experience. I guess one of the questions I want to ask, inside these walls, they're about like 1.5 feet wide or so. What does the inside look like?
So the inside is, where necessary, we have a sort of top to bottom structural anchor that like will anchor into the foundation and sort of bolt into a top plate. I'm pointing as if the camera can follow my pointing, but the funny way to think about it is like almost like a post-tensioned wall system, if that makes sense. And sort of you have like an anchor in the floor and then you sort of anchor to a top plate. And so that's going on. And then right now we're using an open cell foam insulation inside. These walls, we did that just to kind of, this was sort of a pull out the stops project. We were informed that these walls would have certainly passed code without the addition of the open cell insulation, but we just wanted to make them as robust as possible. On some of our future projects, we're going to be, actually our very next project that we're going to be doing, the 100 home community with Lennar, we're going to be using a blown glass insulation inside the wall. So continuing to experiment and learn, but we've done a bunch of stuff in the lab. And so what you'd see is like structural reinforcement where necessary, mostly at like wall endings and certain sort of moments where we expect loads to be high, and then insulation.
I've never heard of blown glass insulation.
Yeah, it's just like glass fibers. It's fiberglass, but fiberglass is often technically referred to like the solid sheet material, and glass fiber is the loose fill material. It's one of the more common and widely used insulations out there. The advantages of like a foam insulation is it does a very good job sealing, but we don't have a big sealing problem because it's, this is all fluid applied when it's printed. And relative to a foam insulation, a glass fiber insulation is going to be more affordable, is going to be sort of less petrochemical
Is that loose fill?
It is loose fill, but you fill it to a certain compaction level that you measure and verify in the installation. Yeah.
Cool. And
so it can't be too loose.
When you have the vertical metal reinforced columns,
yes,
do you have formwork printed inside the wall to accept the...
Yeah, it's almost like you print a form of a column inside the wall instead of an exterior column. You have like an interior column, and then the metal. And so sometimes it can be a very tight, like almost sleeve for the rod. And then sometimes the structural engineering will prescribe a sort of poured column, and then often we'll fill that column with the printer itself. We'll sort of, the printer will go back around like a hummingbird and sort of fill each of the columns.
So each point a structural beam rests on a printed wall, you have one of those floor to ceiling vertical columns?
More or less, that's right. There's occasional exceptions, and there are a few spots where there's like
this one.
You sort of had like a surprising need that wasn't, you sort of wouldn't intuit it without running the actual calculations. But we sort of do the full structural engineering work to make sure that these houses are as safe and strong as possible.
Cool. So as far as the
I want to make sure two other things. That we didn't do the hummingbird approach on this project. We sort of filled those columns more conventionally because. Actually, the printer that printed this project, it was the first thing it had ever printed. So this is like this project was printed by a prototype printer.
Wow.
It's like really funny. And then we immediately sent that printer. The reason we couldn't like have it wait around and do the fill is because we had to run to the Johnson Space Center to do that Mars habitat that you may have. And so like we were like on a deadline, so we had to run it out of here. But
which was the second project with this same printer?
That was the second project with the same printer. Yeah, that was so we're on sort of Vulcan 2 now, and we're on like dot whatever. This was the dot 4.
Okay.
So internally we call it like the 4 series. And so this project and the NASA project turned out to be the only projects that the 4 series will ever do because we learned a lot that we could talk about if you wanted to.
Yeah, please.
Okay, great. We'll talk about it. So the main problem with the 4 series, you'll notice a lot of the like when there's like a nice long span, like the beads are like quite clean and nice. And it really is in the corner where we're experiencing some over extrusion. And it really is sort of a geometry problem, right? Because when you're on straightaway, you're sort of more or less depositing into a square.
The obtuse angles don't seem problematic. It's the, I guess, acute angles.
Right, because when you're opening in an obtuse angle, as you say, like that, the volume isn't changing quite so drastically. It's the worst around the really small acute angles where like the volume of the geometry you're depositing into is radically different than what's being pumped out. And so that was where it would end up being the worst. And so
I noticed on the latest picture you had a picture with all your employees, or a big chunk of them.
Yes.
Great picture. The columns for the icon printer have increased in size dramatically. Is that for increased rigidity or?
Yes, it's definitely for increased rigidity, especially as you go up. You were talking about how the print actually changes as you get higher. Another thing that changes as you get higher is the center of gravity, and the moment of inertia can really start. When you're low to the ground, the printer's quite stable. When you get quite high, you were experiencing some like vibration in the printer that of course translated into the quality of beat. So we needed the system to overall be more rigid. Of course, that's a trade-off for like operational simplicity in terms of like how fast and simply you can deploy the machine if you're making it more robust. The other thing that printer is pre-engineered for is the possibility of doing multi-story printer on that same platform. We haven't committed to the gantry form for multi-story printing. We're exploring presently 3 different basic architectures, but I think you and I will be sitting down at some point and talk about multi-story printing because that's definitely on the roadmap. And so because we knew it was on the roadmap, we went ahead and pre-engineered that frame to basically even stack another tower on top of it, and you've got a multi-story gantry.
That makes sense.
It does make sense, but the gantry, it's quite massive in the sense of like there's a lot of mass once you're printing it 2-story, and so there's some open questions on whether the gantry is the best form factor for multi-story printing. So we'll hopefully have some conviction later this year, and we'll be able to talk more.
Are you able to share how many separate days of printing, getting the printer running? How many different days was the printer running to complete this project?
So the phase for this project is we deployed the printer in a single day. And then we actually did, because this was the first project, it printed and we knew the NASA project, we were kind of in a hurry. We actually did a lot of test printing just out here on the slab, printing that we did not keep or whatever. It was like almost like using this as like an outdoor laboratory. So we did that until we were happy that everything was looking good, working good. And then we cleaned the slab and we pushed go. And then it was 8 continuous days. And it was rainy. As I'll get out, I almost said something maybe inappropriate. It was very rainy for those 8 days. We have some amazing videos and pictures that I can show you, but nonetheless, it was done in 8 days, and then we packed it up in a single day and headed over to NASA. So that was the sort of overall operational cycle.
Wow. Is there any evidence outside of where the printer was standing?
No, so our current rail system it can be adapted to either bolt on to the side of the slab, sit on the slab, or sit freely on the ground next to the slab. And so on this project, it sat freely on the ground next to the slab. So the only evidence is like the spacing we left between this wall and the edge of the lot. That really is probably the only evidence.
So if you have it resting on the ground, you have to take a lot of precaution in advance to make sure it's even?
Yeah, so we did some leveling up the side, of course, and then the rail system we're using right now itself is adjustable. And so we can, like, in fact, because the ADU house is such lower, the rails over there were like, it looked like the printer was floating 2 feet off the ground when it got to that end. And so they're like adjustable across feet. I mean, it's quite an adjustable system. And then every so often, we did this print more or less continuously, but when we would stop for a while, especially in the rain, and we wanted to, you could rerun the printer up and down the rails without printing and sort of make sure everything was level relative to some fixed known points. And so occasionally you'd have to recalibrate or just check your calibration to make sure something hadn't shifted or sunk. And if it had, you adjust the G code and you keep going.
So for the timeline, you mentioned this was one of a series of homes you'll develop to experiment what Icon's capable of now that you're much less cash constrained than you had been in the past.
Yeah.
You also have the 100-home Lennar project. So is it the same printer that will be doing that, or are those simultaneously occurring?
So the 4 series printer that did this print and the NASA print is now getting repurposed as just a test printer. We will never ship it on a commercial project again because of that known issue with over extruding in corners. Okay. So only 5 printers going forward. On the Lennar project, we're planning to deploy at least 5 printers and as many as 10, kind of depending on, as you know, with 3D printing, unless you want to cover the site, you still have to shut down for weather. So kind of depending on the schedule, because we have some other projects that are waiting in line behind Lennar that we haven't announced yet. And so we really do need to make that project go quite. So on the Lennar project, depending on how fast we're making progress, mostly correlated with the weather, we will deploy between 5 and 10 printers. And they'll all be sort of the new 5 series printer.
So I guess it depends your manufacturing speed, and you'll prioritize the Lennar project and do the Icon-owned homes as you get to them. So where we're really headed is we will now have a fleet of printers. We've been in this terrible situation for most of our life where we had to really pick and choose, which is why we've never been able to do our own projects. We had to always prioritize the revenue-generating projects with customers.
And so now we'll have a large enough fleet that we can sort of walk and chew bubblegum at the same time, right? We can both pursue the commercial projects. We can have test printers back at the lab to continue to refine and advance the technology. And we can do our own sort of experimental architecture and experimental housing projects. We can sort of do all of this at the same time. And so that's the kind of work that we'll be doing.
I kind of always wondered when I saw how much money you guys were raising, like why don't they just build 10 printers, 20 printers? But had you built 10 of the first printer you built, that would have been a huge waste. So it was really smart to develop and figure out exactly how you
even now, that's actually one of the harder strategic questions is like, because even the 5 Series, as good as, you know, like it's definitely like our workhorse printer right now. We're going to deploy a dozen of them this year out to multiple projects. But of course, we sort of see what could be next. And so deciding how many of a present generation you want to make, because then you have to like sort of service and support a technology that you can see its end of life is not too far out. And so it really is a dancing, but you have to get revenue as a young startup company. You have to get traction, you have to get revenue, you have to get houses out there in the world, or that's how Icon has behaved. Like house count, delivered house count is like the metric above all metrics. It's not technical maturity. It's like delivering houses that customers will pay for is the metric above all metrics. And so we really do have to keep the show moving. But it really is a tricky dance of like how many to make of a certain generation. And so until the 5 Series, we'd never made more than 3. We had made 3 of the 2.2. The 2 Series, we made 3 of them. And so it's tricky. So you're on to more than you realize.
I'm sure next time we talk, maybe we'll be talking about manufacturing hell instead of figuring out how to.
No, it has been crazy. Our first dozen of the 5 Series printers will be ready in this quarter, and then they'll get deployed out.
Wow.
Yeah. So, and it has been tough. I mean, the stories you hear about moving from 1 or 2 printers to like dozens and dozens of a large machine. It's a whole new set of disciplines and skills that the organization has to learn, and it's been hand-to-hand combat for sure, especially trying to stand up the factory in the middle of sort of, you know, all the global supply chain challenges and stuff. So
yeah. Does the system, I'm sure it uses tons of computer chips, like similar to the ones cars use, but a lot less because you're not building them in thousands or millions of units yet. So the chips aren't a constraint yet.
Well, so funny enough, yeah. So like you're right onto it. Like for us, the PLCs, the programmable logic controllers, were like the hardest to get a hold of component. There are a few other funny objects like the containers for our Macmas. We had to switch containers in the middle of manufacturing because the one we wanted was out, so we had to switch to it, which meant a little bit of refactoring for the internal components. In almost every other supply chain issue we were able to work around. We could do our own welding, cutting, fabrication, but we're not set up to do our own computer chip and PLC manufacturing, so that was a true bottleneck. And you're right, we don't need millions of them, but the result is they tend to preference the people who do need thousands of them. They get to be first in line relative to Icon, who we needed a few dozen. And so that really was like sort of like the most interesting and important bottleneck in the manufacturing process.
I just picture you telling your employees, like, hand over your iPhones, we're scrapping the parts.
Yeah, that's exactly right. That's exactly amazing. Yeah.
So the future printers are going to be deployed all over America, outside Texas?
The projects we have lined up right now that I'm ready to talk about are in Texas. But we have projects that we're not quite ready to talk about yet that are outside of Texas. Yeah.
Sure. I mean, while you're fine-tuning the developments of how you want the houses to be built in the printer, there's no reason to ship it across the country for some showcase.
Although I will say, like, more or less going forward for Icon, unless it's an exploration house, or like, unless it's a project we're doing some very serious research and development to learn things that we can then scale later, we sort of from now on, we don't get out of bed for less than 100 homes. That is the minimum bite size if you want to work with Icon.
That's good for people to know so they don't reach out unnecessarily.
Yeah, that's exactly right, because really, there's so many things we could do, and you could really get this temptation of like you're running too many directions at once. So if we're not careful, we end up in the situation where we're trying to chase down too many kinds of projects, kinds of architectures, kinds of things, all at the same time. And for us, we always come back to this idea, it's like we're trying to solve the global housing crisis, and which it means a lot of things, but it certainly means developing and deploying the technology at scale. You're talking about millions and approaching 1 billion homes that they sort of eventually need to be built, like ideally in our lifetime, and doing 4-home, 5-home, 10-home projects even going forward is just relative to what we could be doing, because we have demand for projects of hundreds and thousands of homes, and so those are the projects we'll be prioritizing as we go forward with a little carve out of this exploration series. And so I'm sure occasionally some things that we want to solve with R&D in the exploration series will match what a commercial opportunity wants, and so sometimes they'll probably be the same thing. But the bulk of our effort will be on deploying hundreds and thousands of homes.
So your manufacturing process, you mentioned you have welders in-house, you have a ton of stuff in-house.
Yes.
The chips are not in-house.
Yeah.
What is there a percentage in-house developed at the printer at this point?
I don't know the exact number that's in-house, but it is the vast majority.
And that's something you strive
Yeah,
for?
the only things that we are not manufacturing are the motors and the chips, basically. I mean, there's probably a couple of the hoses, the concrete, we don't manufacture concrete hoses. I mean, like sort of the obvious commercial off-the-shelf stuff we just buy, but the bulk of the machine is like designed, made, fabricated, and then assembled by Icon employees.
And of course, the material totally developed in-house.
Material totally developed in-house, and we're even going to be moving up the supply chain in material in the coming 6 months to sort of gain some more control over that as well. And
Like mines?
we've certainly talked to them.
That's cool.
Yeah. And so, because there's a lot of cost and margin in the supply chain of concrete, it turns out, and it's not clear that they're adding a lot of value. It's sort of like it came in one side, it went out the other side, and there's like a huge margin that gets added, and the value that was added in that step doesn't seem to be proportional to the charge, except that they just can because they're the only ones doing it. Not wicked people, they're trying to run a good business. I'm not sort of mad about it, but what I'm driven to do is radically lower the cost and time of construction. So,
Is there a future where Icon's processing lime?
there's certainly a future where we are buying futures on raw materials.
Yeah, that's very smart in this inflationary environment.
That's right.
So the material, has it changed, the material of this house versus the other homes on 17th Street?
There are always changes, but there are changes that would, it's more or less the same material, but we're maybe sourcing a certain sand from somewhere slightly different because we like its performance better, or we found a supplier that's closer to home, it reduces shipping costs. But it's like the basic formula is the same. There will be a big shift in formulation after the Lennar project. So we're going to hold what we got because it's really well tested and well understood through the Lennar project. We are going to be doing a big reformulation, mostly driven by a process that I don't want to say too much about, but it involves us like both simplifying the mix and then getting further up into the supply chain to control cost and supply.
I'm going to say batch plant mixer, and we can look back in a couple of years and see if it's relevant.
That's amazing. Yeah. But next time we talk, you can see. But we expect it to we expect it to cut our costs more than in half. By number one, simplifying the mix. In other words, our early mixes are probably over-engineered on purpose. We were sort of belts and suspenders. We want to make sure everything's great. But as you know more and you get more confidence in the behavior of extruded concrete, you can simplify the mix design over time. And then you want to then own what you're doing with that mix. So that's the next step on the supply chain side to like radically decreasing cost.
Absolutely.
A long journey yet. I mean, sort of the romantic idea still is like homes that are twice as good but are half as much, right? Sort of that's the romantic idea, but we're not there yet. But we see a roadmap where there's still like very large gains to be made. Not like 1% and 2%, but like large double-digit 20, 30, 50% gains to be made by doing a few things.
Absolutely. I recently watched an interview with a former Tesla employee, Joe Justice, about the Agile method. And so I wanted to ask, are you guys into the Agile method and your business structure? As much as you can talk about, I'm sure tons of that is private, but how have you structured your business to innovate rapidly?
So you would definitely say that in our past, Icon is a pretty like high-speed, fast-moving company. I mean, we iterate through generations of our technology like quite rapidly, and often like right before deployment, if we can think of a better thing to do, or we discover at the last minute a better thing to do, we will like hyper quick retrofit everything to do the best thing we can do at any given moment. It's not exactly agile, it's just like velocity is literally one of our 3 core values at Icon. And so I think we move faster than the typical sort of large-scale hardware company. That said, a lot of the like behaviors of software, like Agile method, don't exactly translate into hardware development because changing software is cheap and easy, and like changing parts on giant robots that didn't have structural follow-on effects and things like that, it's like
Hard and expensive.
Changing a $10,000 part can have $30,000 of follow-on effects. And so you want to have higher conviction before you start building the first time than you would with software. You can sort of like build, break really fast with software. you sort of need to start a little further down the road, and so you do that with like computation and analysis ahead of time to try to build a little bit more conviction. But that said, as soon as we can think of a better way to do something, we do it. What I think Icon is trying to do right now actually is, as we move toward a world where we have to do manufacturing, which means you have to have a much more stable product. Then in the past we had 2 or 3 of them. It was like, if that doesn't work out, it's no big deal to change it on 2 of them. But if you have 50 of them and you pick the wrong motor, it's a very expensive decision. And so we're actually trying to add a little bit more robust systems engineering to our process and sort of keep a separate R&D silo where like they're operating quite fast. They can break things quite easily. There's like the stakes are lower. But as you move over into like product development, something sort of makes it over the fence from research to product. That needs to get a little bit more rigorous and stable so that as we then manufacture that thing, we can count on those construction systems to work for like years and years out in the field. And so a little bit more rigor is actually what we're adding, but we don't want to give up our high-speed, very agile culture at large. So trying to figure out like what's the right level of systems engineering at Icon is a trick, but we're certainly looking at companies like Tesla and SpaceX. We think these folks, relative to their peers, have shown that you can do a very high quality but also high speed engineering cycle.
So you've begun to separate a little bit your business activities with Lennar from R&D activities like this home.
That's exactly right, and that's one of the things when you're a young company that's very resource constrained. Your prototype printer also has to be your printer that makes you money.
It's all both.
Yeah, that's right. And now we're able to sort of divide and do development with a little bit freer hand because there's not some project weighing it down. We still, of course, set milestones and goals and budgets and that kind of thing. And then the commercial project, which is sort of like, we have a very stable core product, sort of the 5 Series Vulcan, and that's like our breadwinner. And that product needs to be pretty darn stable so that we can just continue to deploy it and keep going.
Does that mean you have another product?
That means we are certainly developing other things based on what we're learning.
Cool.
Yeah, for sure. Yeah, Vulcan, 3 years from now, 2 years from now, maybe even a year from now, like our current Vulcan will not be the state-of-the-art printer. It'll be a workhorse still. It'll be like, it'll deliver houses at least this good, which is pretty darn good. We've got to go faster. We've got to print with more accuracy, and we're going to eventually have to go taller. So those are sort of some things. Yeah, bigger, faster, bigger, faster, cheaper, taller.
Cool.
Yeah.
Taller, bigger, faster, cheaper, taller.
Bigger print volume, taller reach. Faster printers, more accurate, more beautiful.
Do you think you'll continue to do separated elements like this, or will you do more monolithic homes in the future?
So I think it's underappreciated in the space, but we are trying to appreciate it. We have a whole dedicated architecture and building performance team led by a remarkable woman named Melody, who I hope you get to talk to one day. I think as you start moving into like multi-story printing and some of these things, the architectural challenges are actually just as substantial as the engineering challenges. And what I mean by that is like, for this to really work, you have to want millions of people to want 3D printed homes. And that's not just an engineering question. That's like a human culture, beauty, aspirational question. And I don't think enough people in the 3D printing space are asking that question seriously enough.
Well, I only have 29,000 subscribers, so hopefully when there's 1 million people that want 1 million homes,
we're going to win together. That's exactly right.
So for the other homes in this explorative series of architecture, what kind of things, is there anything you can discuss that you'll be experimenting with?
Yeah, I mean, I think some of the things on the list would be pretty obvious to somebody who like stares at the space as much as you. I mean, one big open question is like, what else can the 3D printer do besides the walls? I won't say more than that, but it's like getting an answer to that question in a real house that people would want.
I mean, just looking around, that.
Yeah, and so like what else? And ultimately, like from a business perspective, could you deliver the full enclosure? Is a very interesting question in a way that's intriguing that people want. So keep an eye out. And then there's some like real like regional specific questions, like what would a house look like if it was designed for wildfires? What would a house look like if it was designed for hurricanes?
Tsunamis.
You got it. Like sort of like really like, I think we're sort of getting to that inflection moment where like 3D printing on its own 2 legs with no sort of like hold your tongue in the side of your mouth or wink wink is going to be a better choice than conventional construction. But then there's these certain moments where like 3D printing has like a real unfair advantage, and it often is all related to like natural disaster because you're using a first principles resilient material. And so like where is that going to give you an outsized advantage, and like really double clicking on those things. And so resilient housing is an interesting area of research at Icon right now.
After doing this home without sacrificing the integrity of the printed walls, as your architect would say, will you continue to use these electrical methods in the future, or do you think other homes will have the electrical?
Yeah, so the idea is with all the exploration series, some of the things you do in these houses, it'll be like one of them will never do it again, but we're learning some other things. Like these are now permanently part of the product offering at Icon. Like I brought the leadership of Lennar out here and showed them these walls. Like, why are we doing this? Because like this wall is the same price, right? Like again, the things that drove cost on this house are like the fancy faucets and the Wolf appliances or whatever. These walls are half the price it would take Lennar to deliver these walls, and they're the best. They're the best in the game right now.
In concrete or stick built?
Yeah, if they wanted to replicate our walls with stick frame, we're half the price today.
I'm sure concrete
with
would
no
be
fudge factor, right?
Expensive too.
Yeah, the formwork that would be outrageous. And so like Lennar, they're a good example because they're the largest, fastest, most affordable builder in the Western Hemisphere.
Wow, great partner.
And so they're the deep end of the pool, right? So if you like, they're already 30% cheaper than Joe Builder down the road. And so using them as a partner and a foil for our work is like if we can outperform Lennar, then we win. And so 3D printing, we've reached the moment where 3D printing is a marketplace winner. And we aren't done optimizing yet, not even close. So,
is there anything you can mention, like something design-wise you wouldn't want to test like half in the house out? So, is there something else another house would have, like that you can kind of leak or give a little hint towards?
I mean, the big areas of research at Icon are speed, cost, delivering more with the 3D printer, full enclosures, other kind of elements, and then like resilient housing.
Would you ever consider material that can do an overhang?
Yeah, that's architectural, but the overhang is only interesting to me if as I sort of said earlier, I don't just want to show off.
Not for aesthetic purposes, for function.
Or like it'd have to be a very strong aesthetic purpose.
Like a social aesthetic purpose.
Yeah,
like
a lot of you've probably seen folks out there. For me, it's all very interesting. I mean, I watch the videos too, and I think it's so freaking cool. But eventually, this has to work outside of the lab. It has to, and so like we're just so laser focused at Icon of like this thing that we're researching. We have to have high conviction. Will make a better house. Right, that's sort of the basic heuristic.
We're sitting in it.
Will it make a better house? It's like, oh cool, that thing looks so funky and interesting, but I can look around and if nobody I know would want a house like that, then it's not urgent to pursue. And so we really are like quite serious about the sort of better house proposition. And so those are the big areas of research. Going faster, going more affordable, resilient housing, and delivering more with the 3D printers to the open. But in the future, the most lofty sort of goal is like robots and drones will deliver entire neighborhoods, entire towns, and maybe even entire cities. And that future is for sure faster, is for sure more efficient, for sure has more design freedom, and I think will allow the humans to do the more creative work. In the future, neighborhoods and little villages and eventually like towns and cities are going to be built by robots and drones. And that future is going to be delivered faster, more affordably, more efficiently, with less waste and a lot more design freedom. And so that actually is like the master project of Icon. Because we want humans doing the creative sort of human-centric thing, because hanging, sheetrock, laying brick, these are not the highest and best use of human bodies and human minds. You do what you got to do along the way to build a civilization, but we sort of want to like this to be an enabling and ennobling technology. And so that's really at the biggest scale. We think what we're doing will eventually transcend 3D printing. 3D printing will always be sort of the heart of the thing, but there's a lot more yet to do. And so we're super excited about that future.
Yeah, I can see it now. It's going to be amazing. The drones and other robotics, maybe like whether it's a spot robot or some other type of machine, it would be incredible to integrate that with these processes. Again, once you get everything fine-tuned so that you're not trying to integrate things that are going to become obsolete.
Yep,
but
that's right.
That's incredible. I mean, I'm even considering getting an AI drone and one of those robot dogs so that I can have it flying around taking drone footage while I'm at the site, and the robot dog can follow me with the camera.
Yeah, amazing. Totally should do it.
I think within the next 2 years, without a doubt, I think I will. But because I don't want to hire a person, I do so much traveling. I couldn't drag anyone along with me to do 2-day road trips.
But you and your robot family.
Yeah.
Yeah.
And my dog.
Yeah, amazing.
I have a real dog too.
Okay.
But we raised $185 million, and I heard rumors that it's over $1 billion valuation. Without having to confirm or deny those, what's the like expected? What are you going to spend money on?
Yeah, so Icon, historically, we've tried not to make a lot of noise about fundraising, in the sense of like, raising money is not the point. The point is robotic construction. And so we've always tried to make the most noise about the things that actually matter to the world. It doesn't help the world if I raise a lot of money. It only helps the world if our construction systems work and our houses are great. So that's what we love talking about. But of course, you have to file with SEC so these things become public. And so in the past 12 months, we raised an initial Series B that was very much instigated by us. We wanted some capital. We knew what we were going to do with it. And that round was led. It was a little over $200 million. It was led by Norwest Capital. And just a few months after closing that round, we were approached by Tiger Global, who's like a very well-known, well-respected, quite large firm. And they were very bullish and excited about the things that we were doing and wanted to also invest. And we said, well, we just closed a round.
People kept knocking and made you an offer you couldn't refuse.
That's the shortest way to say it. That's exactly right. And proved to be like incredibly helpful, great people to work with. I would say that as well. We've been in the very fortunate position for all of Icon's life to we got to choose who our investors were. We've almost always turned away more money than we took at every step. And so like I'm now very protective of the people who are like on our cap table and our investor base, because they're all such tremendous assets to the company. So we don't need anybody who's going to be a drag on the company right now. And so Tiger proved to be those kinds of people. They were incredibly sharp, provided us a ton of extra resource in addition to their investment, and so made us a deal we couldn't refuse is exactly right. And so now we have like a nice war chest that we didn't plan on having. And so for right now, it doesn't actually change the plans a lot. The big goals for Icon right now are to achieve a 1 house per day run rate. So like in 2018, we built the first house, we had 1 house per year run rate. Over the last sort of 24 months, we've delivered about 2 dozen homes for about a house per month run rate. In the coming year, we should deliver about 100 to 150 homes, so a house every 2 to 3 day run rate. We would like to get to a house per day run rate as a company. Number 2, we want to mature business around our core technology. We want to fix and stabilize part of our product and have a profitable, functioning, mature business in-house. And then number 3 is launching some of the digital tools that we think will support the work of 3D printing.
Okay, wow.
Up and down the cycle. Yeah, so our long-term initiatives, in addition to those 3 core goals, number 1 is like Vulcan Next, like where's the printer and all the automations going next? What else can we make go faster, cheaper, more beautifully, etc. Number 2, the project with NASA. That's not the kind of thing that comes to a conclusion in 12 months, a very long-term program. And number 3 is a heavy R&D, this exploration series, heavy R&D into like long-term architectural futures. What is the architecture that's purpose-built for 3D printing? And so those are the things that we'd already agreed to fund and to pursue as a company. And now the idea is like we kind of get to just do those things except harder and faster. Right, we're not sort of adding a bunch of other stuff. But the other thing that having such a nice balance sheet will allow us to do is like when we discover what Vulcan Next is or what other automations we want to add, we can pursue them unbelievably aggressively without having to sort of drop anchor for a minute, spend 6 months raising money. It really just allows us to go faster and harder.
You're going to build over 100 homes in the coming year?
Yes.
2022 or 2023?
2022, we should build
wow.
Meaningfully more than 100 homes this year.
That's incredible.
Yeah.
I'm kind of blown away. I mean, they must already be working on them.
Yeah, we're already working on them.
I might have to do some laps around Austin.
Yeah.
Wow, that's so amazing. So there's going to be more projects than I can possibly film. My hopes of filming every 3D printed house has gone down the toilet.
Yeah, I think we have something like 500 homes under contract and several thousand in LOI stage.
Wow, so the 500, is that between more than 5 clients or?
Less than 5.
The digital tools that you've been working on very quietly, what I would imagine is like design tools so that you can, maybe a 5-year-old could play with an iPad and make something printable and the iPad could say, hey, you can actually print this.
You're very close. The way to think about it is like the entire construction industry needs to either be automated, i.e. robots, or digitized, which is like a software automation.
Mm-hmm.
But just, that's how we talk about it internally. It's very public that we're pursuing certain robotic solutions. But we're also highly interested in the other things, because ultimately to get to that romantic idea of homes that are twice as good, delivered in half the time and half the cost, you're going to have to automate the whole thing, either with software or with robots. And so we've had a very quiet but vigorous digital effort underway, and we'll be launching some of the tools this year. So think all the way back to the beginning, all the way to the end. decide if it needs robots or software, and if it needs software, or we're looking and developing all of it, is the thing to say.
Any of these tools, are you taking the Apple approach of exclusivity all within the Icon realm, or the Android approach of some open source stuff?
I think ultimately for our mission to succeed, we have to develop and build things that other people can adopt and use.
Wow.
And I think Apple's approach is probably closer to what I'm saying, because they're not as closed as maybe they were in the beginning. They're
Sure.
sort of this like, you do have to sort of set the ground. And for us, like, a great example was like, I don't ever want anyone to be allowed to use an Icon printer to build an ugly building. And so like, I have to have that kind of control. Like, it turns out I'm the kind of person who it matters to me what my technology builds. I don't want the same world just built like shittier and faster or whatever. I don't know if I can say that on your channel.
Absolutely.
Oh, perfect. I want the world to be better. And so I have to have enough control to make sure that like, you're not using a 3D printer to make a massive profit on the backs of the very poor. You're not ignoring sustainability, human health, and the beauty of communities. Like, so we have to set up a system to where those things can be true, but then empower people who like believe in that world to use it and adopt it aggressively. I mean, that's sort of what we have to do.
Very cool. I like that answer a lot.
Yeah.
Well, I want to thank you and Brooke for allowing me to film this house with you, take the time to do this interview. You answered so many amazing questions and told me about so many things I had no idea. I guess the industry is progressing even faster than I thought it was, and it's nice to hear. I'm revitalized in terms of excitement for what's coming in the future. And I want to ask, is there anything else you can let the audience know, anything you're working on that they can go check out?
Yeah, one of the coolest things that's happening right now is like South by Southwest is back on for this year after a couple year hiatus due to COVID. And we love South by because we're based in Austin and the whole world comes to Austin. So we always try to like let the world in on what we're doing. Like sort of wherever, every year you can sort of count on Icon to like show where we're at. And so this house is the big feature for us at South by this year. And so if you're in town, sign up to come see the house. You can go to our website, there'll be ways, or go check out our social media, there's ways to sign up to come visit the house if you're in town for Austin. I'm also doing one of the featured talks about sort of where we think all this is going and what it's going to look like to build the future. So if you're in town and you want to come to any of that, we love having some fun at Icon when we can. Number two, we are hiring unbelievably aggressively. I think this time last year we had somewhere between like 30 and 50 employees. It's March now, so yeah, that's kind of the right range. We're sneaking up on 300 right now.
Wow.
And we're going to like probably double again. And so we are hiring scientists, engineers, operators. I mean, basically every division of the company is hiring to support our sort of very ambitious goals as we sort of graduate from building like a few dozens of homes in a few years to building hundreds and thousands of homes every year. Because after a home per day, we got to get to a home per hour, a home per minute, a home per second. And at a home per second, we have some hope of solving the global housing crisis before we die, which is that's the idea.
So a home per second breaks down to how many homes in a year?
I forget off the top of my head. It'll get you 1 billion homes in our lifetime is what it'll get you.
I know that song's 525,000 minutes, so that times 60 is about 3 million a year.
Yeah.
That's an incredible run rate.
Yeah, and that'll give you a shot at doing 1 billion in our lifetime.
Wait, that times 60 is 30 million a year.
So, but if you reverse engineer, if we can get to where like the printer's dependably delivering a house per week, and then you can sort of do the math on how many printers you need, it's less printing systems than the major car companies make automobiles every year. So it is a number that's believable in the sense of like, we know how to make large heavy machinery at this scale already as humans. It's now making it real. There's 1 billion home shortage at least. I think at 1.4 billion, actually is the number I saw. But let's say it's 1 billion to keep the math easy. That means even if we built 1 million homes per year, it would take us 1,000 years. That's depressing. That's 950 years too long. And so you got to keep adding zeros to things. And so this is why, for now, going forward, we don't get out of bed for less than 100 homes. And soon we won't get out of bed for less than 1,000. And so I think that world where like robots are building entire communities is faster and closer than most people realize. And we are dead set on making it happen.
And whether it happens in our lifetimes or not, you're definitely making a big impact in speeding up how long it takes.
We're doing what we can.
Cool. Thank you.
Thank you, boss.